All right, so we start up chapter 3. Not everyone was able to stay inside the classroom for the entire chapter, so I wanted to record a quick video, try and help folks out with this. So this is going to go over some of the chapter 3 information. If you missed something, this will help catch you up to speed. So first of all, chapter 3 is about displaying and describing categorical data. So I just want to remind ourselves, categorical data is a type of data that we cannot do math with and come up with a meaningful answer. So there's 3 rules of data analysis, and this is for following along in guide notes. Primarily, we want to make a picture, make a picture, make a picture. By doing so, it'll help us see what's happening with our data. So in this section, we're basically going to go over how to reveal information that isn't very clear or easy to see inside of a table of numbers. So we make pictures of it to look for those patterns and relationships that could be hidden inside of the data. So there's some assumptions. Anytime we're going to make a picture like these, we have to make sure our data is categorical before we use any of these types of displays. These displays can only be used for categorical data. So we did a class poll, and I just put some numbers in here because we're going to need something as we go through these. People identified as male or female, and if they self-identify as liberal, moderate, or conservative. And we didn't define these, just did they identify as this. So honestly, we don't know what they might have meant when they said it. We've seen some numbers out. So we had gender, political view, and we had our statistics class, how it worked out. So first thing is a frequency table. Frequency table just records the total and the category names. In this case, I just have political view and how many total. I've lost my gender information in this. I just have the total. We had 12 people self-identify as liberal, 5 as moderate, 5 as conservative in this example that I have. So we have a grand total of 22 people. These are useful, but sometimes we want to know the fraction or proportion of the data in each category, so we get a different table. That's called the relative frequency table. It displays the percentages for each one. So for liberal, and let's make sure we're not going to skip past this, we take the counts and divide by the total number of cases. So we had 12 divided by, and I'm playing with calculator on another screen. You're not able to see it up there. So we said we had a total of 22. So we need to do 12 divided by 22, and we get 54.5%, or we can just write it as 55%. Oh, it doesn't want to write on the screen. It doesn't want to let me write. Okay. So we'd say 55%. Next case, moderate and conservative were both 5 apiece. So 5 divided by 12, 5 divided by 12, or 5 divided by 22, I'm sorry, gives us each of those to be 23%. Now, because I'm rounding, these are not going to add up to 100%. In fact, I adjusted conservative downward in order to affect that rounding. Where probably what I should have done is left moderate and conservative both at 23 and left liberal at 55. And yes, it rounded over to more than 100%. Using that simply because we were rounding off that decimal place. 54.5%, 22.7 for each moderate and conservative. Now, in using this, we get to see a distribution of categorical variables, so we can make a picture. Okay, doing that, we can first of all use a bar chart. It just displays the distribution of a categorical variable, showing the counts for each category next to each other for easy comparison. So in this case, we can do it on a bar chart this way, and we had our counts liberal, moderate, conservative. So we'll put in some bars to show this. So for liberal, we said our count was 12. So I'd make a bar for liberal, going up to 12. And then moderate and conservative were both 5. So I'd make a bar going up to 5 for moderate. And then I'd make a bar going up to 5 for conservative. And of course, in order to complete our graph, I have to tell people this is a frequency. Now, a couple things to note. This is a bar chart, bar graph, bar chart. So my bars do not touch. That would be a histogram. So it's very important to make sure my bars don't touch. Now, let's see what we can use this for. Or, I'm sorry, another way we can use these. Let's go back into it. We can also do them as relative frequency bar charts. In this case, as we see, we're talking about percentages on our bottom. So instead of doing count, we're going to do percentage. And this time, we're going to do them as horizontal bars. So for liberal, again, 12, or we said that was, if I remember correctly, 55%. Let me just make sure. Yeah, 54.5%. So I'd make a bar for a liberal. It goes out to 55%. It's just being a little difficult here. Try it again. Okay. For moderate and conservative both, we said it was, oh, that's just incorrect. Said they were both 22%. So for moderate and for conservative, they're about the same. And again, because this is a bar chart, my bars don't touch. Now pie chart. Pie charts show the whole group, everyone, except that we show them as relative frequency. Pie charts have to be done as relative frequency. So you're going to do percentages here. Now again, we said 24%, and normally you want to do these in, bring that back. We want to do these in descending or ascending order. 55% was liberal. So we take almost half the pie. So I come down to the center point of the pie and then just slightly larger. And I'd identify this as filling liberal. And I may even put the percentage just to make sure people know what it is. Now the other side of the pie, we divide evenly between the other two. Now this is a little bit more than half, so I'm not going to draw a horizontal line in the center. We'll just go slightly upward. Just to show I'm cutting these in half. And I could call these conservative, moderate, and we said each was 23%. And we can label that. At the very minimum, if all I'm doing is coloring in the graph instead of labeling what it is, I would have to write a legend next to the pie chart. You can also see it sometimes called a circle chart. But I would have to put a legend off here to the side, perhaps, where I'd explain. And I'm trying to write with a mouse, so obviously this is a little difficult. And I'd put what each one was. I'd probably color them each a different color. Now, one of the things we want to do is when we make pie charts, there's certain rules. We don't want to violate the area principle. And what I mean by that is this was actually given at an Apple presentation by Steve Jobs, where he showed this pie chart. Now, the information, though, was that blue, RAM, had 39% of the market share. Apple had 19% of the market share. And as we go through, we have other at 21% of the market share. Although if I look at it, the percentages and the area in the graph don't seem to match up. That the 19.5 here looks almost like a little bit more than half of 39, and that's true. But it also looks like it's more than this 21%. And the reason it's doing this is because this pie chart's been tilted to try and make it look 3D. So sometimes people like to do it because they think the chart looks good, but it's violating the area principle. The area of the green, the magnitude of green that we see for 19.5 is greater than the magnitude for 21. That's violating the area principle. It can look like this. Let's say I had the Titanic and class of passenger on it. And if I look, I could see third class and second class put together about the same size as the crew. In fact, that's a little bit more than the crew. But that can be really hard to see over here in this graph, where it's written as a 3D graph. So making that 3D pie chart can definitely look like you're violating the area principle, because as it changes that perspective, it makes the values that have been brought to the front of the pie chart potentially look larger than the ones in the back, but at the very least, they make them look like they're larger relative to this than they are over here. Okay, so some people like the ones on the left for aesthetics, but for communicating information, you want to avoid them. Okay, Now, the other thing is pie charts and bar charts have to be used when categories don't overlap. This was a graphic that was produced by How Stuff Works. And it had a recidivism rate of prisoners, and they have all kinds of problems with this. First of all, it adds up to well over 100% of the prisoners. The problem is, so why would this happen? And if we look at it, it's probably because someone landed in more than one category. You could have had someone who's arrested for multiple offenses. They could have been a violent offender and have a public order offense and have been a released prisoner. So there's a lot of, or I'm sorry, there's just a lot of overlap in this graphic, so it's not a very good graphic. They tracked a lot of people, they had lots of information, but they put it together in a bad way to try and communicate it because it's just not clear what's going on in this. You know, how many of the prisoners who were arrested for recidivism had committed a property crime as opposed to a drug offense? There's just no way to know because these add up to more than 100%. Now, again, though, there are some ways this data could show. If this was a number of people on a table, how many property offenses were there? How many drug offenses were there? That wouldn't so much be a problem. But when they're trying to categorize one group in categories, you can't have overlap between the categories like this. That brings us on to another type of display we can use. We can use a segmented bar chart. It's a kind of bar chart that's used for comparison of relative frequencies. So it's kind of giving us a little bit of the pie chart and a bar graph and relative frequency all in one. Now, something we want to remember is when we use relative frequency, we're going to get those percentages, which means we're going to lose the counts. We won't necessarily know how many people were interviewed. We'll just know the percentage that gave a certain type of responses. So, for example, if I did an interview, and in this we interviewed 200 adults shopping at a supermarket, and we asked them about how much education they had completed and whether or not they smoked cigarettes. These are some results I'd get. I had 32 of the people I interviewed had high school diploma and were a smoker. 61 of the people had a high school diploma and were a non-smoker. So my total for high school diploma is given on this row of 93. Two-year college and were a smoker, where there were 5 people there. 13 people who had a 4-year degree and were a smoker. So our total for smokers, we'll change color just so it's a little bit easier to see. Our total for smokers, or smoker information, is given in the column. Using this, we can compare and come up with some relative frequencies. Now, to do that, let's think about our first one. My first group is going to be smokers who had a high school diploma. That was 32 out of 50. We'll go back to the chart. So I had 32 out of 50. What percent of the smokers had a high school diploma? I had 64%. So what percent of non-smokers had a high school diploma? Well, that was 61 high school diplomas. Go back. 61 out of 150. So I'm breaking this category down by smokers and non-smokers. So it's always out of smokers or out of non-smokers. So my smoker with 2-year degree be 5 out of 50 or 10%. And my non-smoker with a 2-year degree be 17 out of 150 or 11%. Smokers with a 4-year degree, 13 out of 50 or 26%. And non-smokers with a 4-year degree, 72 out of 150, or it's going to give us 48%. Now this information I can now turn around and categorize into my segmented bar chart. And we're going to try to write it on the screen again. Don't think it's going to work too well. So I'll say this is my smokers, and these are my non-smokers. So in my smoking category, 64% have a high school diploma, so a little bit more than half. So there's my high school diplomas. And if I go to my 2-year degree, it's about 10%, so let's just call that 10%, and that's my 2-year degree, and the last are my 4-year degrees. My non-smoker side, non-smoker, 40% have a high school diploma, so a little bit down there. Non-smokers 2-year, 11%, so about the same as it was on the other side, 10%. So I have my high school, we have my 2-year, and then we have my 4-year. Now if I look at this, let's put it slightly nicer. Now we can draw some conclusions. So we can look at this, a little bit nicer chart. So some conclusions we might be able to make. If I look at this, I see that high school graduates who stop there seem to be overrepresented as smokers because they make up a larger percentage than they do in the non-smokers. On the other hand, the non-smokers are almost twice as likely as smokers to have 4 years of college, because they said, what percent of the non-smokers had a 4-year degree? Now, if there's no association going on at all, I'd expect these percentages to be about the same. Also, so the non-smokers tended to have a higher education level than smokers. Tended to. It's that 4-year difference. They go into that 4-year college for some reason. Now, does that mean that kids who smoke in high school will quit when they go off to college? Well, maybe it does, maybe it doesn't. Maybe smokers can't afford college because of all the money they're spending on cigarettes. Or maybe college kids can't afford cigarettes because of all the money they use on erasers in math class. We don't really know what's causing it. Therefore, we use the phrase tends to. We're not going to say what causes it, but it tends to. They tended to be more educated if they were a non-smoker. Now, this brings us to a couple last ideas we're going to have. We have contingency tables. This is where it shows the individuals are distributed along each variable, contingent on the value of the other variable. So in political views, now we had our male with liberal views, moderate views, and conservative views. So we had 4, 3, and we said 2. For our females, we had 8, 2, and 3. So our total for our males, we interviewed 4, so we interviewed 9. And for females, we interviewed 13. So a grand total of 22. I can fill in my totals, which are always a good idea to have on your tables. Add the totals on there if they're not already there. And let's look at how that could work out. So what percent of the class are girls with liberal political views? So go back and look. What percent of the class, so of the class, it's telling me my denominator. So of the class is the total, that's 22. Girls with liberal views, or females with liberal views, that's 8. We'd have 8 out of 22, and convert that to a percentage. Now, pull out my calculator here. So I have 8 divided by 22, and we found 36%. 36.3%, says 36%. What percent of the liberals are girls? So now we're not talking about everyone anymore. What percent of the liberals? Well, there's 12 liberals, 8 of them are girls. So 8 divided by 12. And that's going to tell us 67%. What percent of girls are liberals? So girls, there's 13 girls, 8 are liberal. And we come up to 62%. So we can figure out these relative frequencies. These are conditional probabilities. Conditioned on, we're only talking about liberals, what percent girls? Conditioned on, we're only talking about the girls, how many of them are liberals? Now, this is where we start to get a marginal distribution from political views. Marginal distribution is a frequency distribution of one of the variables in the margins of the table. For example, in our liberals, we said in our interview we had a total of 22 people, and we interviewed 22, and 12 of them self-identified as liberals. So it'll be 12 out of 22. Our moderate views, we said, were 5 out of 22, and conservative were 5 out of 22. So we did our math before, we came up with these percentages, and we'd have our marginal distribution. What was it on the margins? Again, should have been 12 divided by 22, just like to make sure, again, because I don't have it written down here, 55%. And then both of these were 23%. And again, because I'm rounding, they're adding up to more than 100%. So we have our marginal distribution. What was the margin? Someone could say, and this is where we did our do now. On the next day, we talked about in chapter 4 how to do a marginal distribution of other values. So what percent were liberal, what percent moderate, what percent conservative. We could have easily said, what was the marginal distribution of the gender? what percent of the group we asked were male, what percent of the group were female. In fact, I have that right here. Was a conditional relative frequency distribution of gender among conservatives. So in this case, what I do is, what percent of the conservative identified as male? And if you remember, for conservative, 2 out of the 5 were male, and 3 out of the 5 were female. So my conditional distribution, 2/5, is 40%. And of course, that means the other 60% had to be female. So it's just a distribution of one variable, gender, for those who satisfy some condition on the other variable. In this case, we said they had to identify as conservative. So are gender and political view independent? Well, we compare the conditional distribution. We'd solve for each. So for male conservative, we have come up our conditional distributions. We had a total of, let's pull up our numbers again. When I get them in here, we had a total of 4 men identifying as liberal, 3 identifying as moderate, 2 identifying as conservative, 8 female identifying as liberal, 2 as moderate, 3 as conservative. And then we have to do it out of the total. So for men, that's a total of 9. For women, that's a total of 13. So I take all of these and divide each by the total. So in this case, 4 divided by 9 is 44%. 3 divided by 9 is 33%. 2 divided by 9 is 22%. Now I do for the females. 8 divided by 13 is 62%. 2 divided by 13 is 15%. And 3 divided by 13 is 23%. Now, the reason I did this, let's look at our original breakdown of 40% male were conservative, 60% female were conservative. What we're seeing, though, okay, and this is a little tough to see at this point, we're in practice these, our percentages of the totals don't match the percentages here. Because we also say, what percent of our total people were conservative? Well, that was only 5 out of the 22. Or 22%. So our conservative actually is kind of close to what the total was. But male conservative was 2 out of 9. So knowing someone was male, and their chance of being conservative is 22%. The original chance of being conservative is also 22%. Let's look at male liberal. Originally, the chance that someone would have identified as liberal, that was 12 divided by 22, we got 55%. That was a chance a random person out of the whole group was going to be liberal. But in this case, if we found out they were male, now what's the chance that they're going to identify as liberal? What's a 44% chance? Knowing their gender changed the probability that they were going to identify as liberal. Instead of being a 55% chance, now it's only a 44% chance. That's telling us it's not consistent in all the cells. So the variables are not independent. If it was the same in all the cells, then they would be independent. Now, in this case, there is some type of association. We just don't know what it is. We don't know why it would be, but we just know there is an association. Now, it brings us to the last topic for the chapter. It's called Simpson's Paradox. And what this is when averages are taken across different groups and they look like they contradict the overall averages. So let's say it's the last game of an important game. Your team is in a rundown with the bases loaded and 2 outs. The pitcher's due up, so you're sending in a pinch hitter, someone to hit on the pitcher's behalf. There are 2 batters available on the bench. Which one should you pick to bat? So let's look at their success history of these 2 players. Player A has hit 33 out of 103 pitches, so you've got a 32% chance, versus 45 out of 151, or a 29% chance. So you have 29, actually at 0.298, and 33 out of 103, so 0.320. So looking at overall, player A looks like the best one to pick for this. 320 versus 298. So A looks like a better choice. But then I can look at some of the breakdowns of the numbers. When they go up against left-handed pitchers, they hit 28 out of 81. So 34, 34.5%. But 12 out of 32 is 37.5%. Well, 5 out of 22. Maybe they're just much better there. 22.7%. Well, how about 33 divided by 119? Oh, 27.7%. So if I look at the overall numbers, player A looks better. But if I look at the individuals against different types of pitchers, player B is better in both cases. This looks like this is what we mean by Simpson's paradox. If I look at the data different ways, I get conflicting answers. B has a higher batting average against both and left-handed pitchers, even though his average overall is lower. So I have to figure out what's doing this. What would be causing this? Well, in baseball, B is hitting better against both left and right-handed pitchers. So no matter which pitcher, B is going to be better. But his batting average is lower. B sees more right-handed pitchers than A. So let's go back and look at that. Right-handed pitchers. A's only been up against 22 times. B, 119. Right-handed pitchers are harder to hit against. So A is being mostly used against left-handed pitchers. So A ends up having a higher average. Now, that's the Simpsons paradox. So you can get conflicting information. Also, I want you to take a look in the textbook and read chapter 3. They have another example in there about a Simpsons paradox, which I think is a good one. So I have some suggested problems. I also posted the solution guide to these. Graded questions are coming from WebWork 2. And don't forget when you log in WebWork 2, read on the screen where it says, do these additional problems on a separate sheet of paper. There are some additional questions I want you on a separate sheet of paper that came out of the suggested problems. And don't forget, print out the guided notes for the next chapter. In fact, we've already started the next chapter, so you should be able to do that already. But I look forward to seeing you all in class. I hope this helped you out a little bit. Make sure you read this chapter and be ready to ask questions if you still have questions on this subject.